This video is to show you how to analyze the data collected as part of a time study and to figure out what our labor standards are, the standard time. And so I'll use some terminology as I demonstrate how to analyze this data. So this is data from 10.12 at the end of your chapter, the supplement to chapter 10. What we have here is they basically looked at a lab test that was being conducted at a hospital, and they broke it down into 4 elements. And so these are the 4 elements. And then they made 5 observations at random time. So in regards to element 1, whatever element of that lab test, however they divided it up, they basically divided that lab test into 4 chunks. And then they made observations of each element, and they did 5 observations randomly, so at different times of the day, different days of the week, and they determined that these were the 5 observations. Now, even as I look through all the elements, element 2, element 3, and even element 4, it doesn't appear to be any outliers. That's something you want to look for. Anything that seems to be really short or anything that seems to be really long, you may want to throw those out because perhaps something happened to cause that. But all these numbers seem to be pretty consistent. So we don't have any outliers in this case. Now, as they were making the observations, they were rating how well the individual did on that. And so basically 100% means that they are average. So this is the average or as you will see here, when we multiply by the performance rating, we'll be able to use that score as is. Now, they said that this on element 2, the individual is a little less than average. They're not quite as good as the average person, but on element 3, they're actually better, and then on element 4, they're like the average person. So the first thing we need to do is figure out what the average is for the 5 observations. And so in Excel, we can use the function average. And of course, we need to highlight these 5 observations. And so the average is 1.5. And now we can copy that down. Oops. Here we go. And we'll double check to make sure that it's doing right. Yes, it averaged these 5 observations for element 3 of the lab test. And so we have the averages for each one of the elements. So the average for element 1 is 1.5, element 2, 2.3, element 3, 1.7, and element 4, 3.5. Now we need to multiply by the performance rating. So we're going to take this, and we are going to take that and multiply by the performance rating. And so of course this is going to give us exactly what we have because we're saying the average on element 1 is 1.5 minutes, and this person is very typical of the average person, and so that's 1.5. Now you'll see here that we'll actually reduce this a little bit because this person, remember, is less than the average person, so they can't perform quite as well. So let's copy these down, make sure that we're doing it right. So we'll click on this to kind of show you what we mean. So instead of 2.3, and knowing that this person is below average, we would calculate that, and what we would say is that a normal person or an average person, need to be careful in my terminology, an average person should be able to do it in 2.07, so a little less. Now in this case here, you'll see that here this person's above average, so we wouldn't expect a person to be able to do that in 1.7 minutes. And so the average person, because this person is above average, we would expect the average person to take 2.04 minutes. And of course this stays the same because this is an average rating. If we add these all together, we have what we call normal time. That's just to do the lab test. Remember, the idea here is that we broke the lab test into 4 parts. Some processes may be more complex, may have more elements to it, but this particular lab test that we made observations, we felt like there were 4 components of it, and we made observations and rated. What we're trying to say is that this individual over the entire lab test, or performing that lab test, is not average on all of the elements. So in some cases he's average, in some cases he or she is below average or above average, and so we've broken it down to be a little bit more precise. Now we need to do one more thing in regards to standard time. So we would be able to expect that if we were to do this test, that most people should be able to do it. The average person should be able to do it in 9 minutes, 9.11 minutes. However, we need to build in some allowance. And so in this model, it says that it's giving personal time of 6%, so that for you to do something that is related to you personally, a fatigue allowance, and doing test after test after test after test, there's a fatigue allowance of 6% and a delay allowance. You might be waiting for something, for a machine to finish processing. And so if we add those up, we wind up with 6, another 6%, there's 12, and we wind up with 18%. And so the way we do this to figure out standard time is that we would take this, and we're going to divide it now by 1 minus the allowance factor. And remember, this is the case where we had 6%, 0.06. He'll do it in decimal form. Another 0.06 for fatigue, and another 0.06, so it adds up to 18%. So we minus that from 100%, or a 1, and we would wind up with standard time. And so we can reasonably, in regards to labor standards, this is what we call standard time. This is normal time here, so we could label that normal. Normal time just takes into account the performance evaluations. Standard time actually takes into account then the allowance factor. So we can expect an average individual to be able to do this lab test, one lab test, every 11.1 minutes. And that builds in a certain amount of time for delay and getting a drink of water, or just taking a break for a few seconds, or whatever the case may be. But you can reasonably expect then lab tests can be done every 11 minutes. And so that is how we do time studies and process the data.